In this lesson, we will learn how to use coefficients to balance chemical equations. Coefficients are simply the numbers we see before a chemical formula in a chemical equation. When we balance chemical equation, the first thing we need to do is write the formulas for reactants and products on the appropriate side of the equation. Usually, this process is already done for you. Next, we count how many of each element you have as the equation is written. 3. We try different coefficients in order to get the amount of a particular element to match. The last step should always be to check your balanced equation. When we're adding coefficients, we always want to use the smallest set of whole number coefficients to balance our equation. Let's look at some examples to see how this process works. We're given the reaction of nitrogen plus hydrogen yields NH3. The first thing we need to do is set up a table so we can figure out how many of each element we have on either side of the reaction arrow. We're going to tally the reactant side and the product side, and we're going to do this for every element that's present. So we have nitrogen and hydrogen present in this reaction. For nitrogen, we have 2 nitrogen atoms because it has a subscript of 2, and hydrogen also has a subscript of 2, so there are 2 hydrogen atoms. On the product side, or the right side of the equation, we have 1 nitrogen and 3 hydrogens. Note that when we're balancing equations, we cannot change the chemical formulas, which means we cannot change any of the subscripts. We can only change the coefficients, or the numbers that go in front of a chemical formula. First, let's look at the nitrogen. We see that we have 2 nitrogens on the reactant side, but only 1 on the product side. Therefore, I need to add a coefficient, and I'm going to add a 2 in front of the nitrogen. When I do this, it changes my count of nitrogens from 1 to 2 on the product side. However, it also changes the number of hydrogens, because a coefficient is applied to everything in that particular chemical formula. So 2 times 3 hydrogens means I have 6 hydrogens present. Now I have 2 nitrogens on both the left and right side of the reaction, so I can say that the nitrogens are balanced. However, my hydrogens are not balanced, so I also need to change the coefficients in order to balance the hydrogens. I see that I have 2 hydrogens on the left and 6 on the right. If I put a 3 in front of H2, I will now have 6 hydrogens on the left and 6 hydrogens on the right. With these coefficients, I see that I have a balanced chemical equation because I have the same number of nitrogen atoms on the left and right and the same number of hydrogen atoms on the left and right. Notice that there is no coefficient, no number in front of nitrogen. When no number is included, that means it indicates a 1. Let's look at another example. We have phosphorus plus O2 yields P2O5. We set up our table to tally up how many of each element we have on either side of the reaction arrow. We only have 2 elements present, phosphorus and oxygen. We have 1 phosphorus on the left and 2 oxygens on the left. We have 2 phosphorus atoms on the right and 5 oxygen atoms on the right. I see that neither of my elements is balanced, and I could actually start with either one, but I'm going to start with the phosphorus for no other reason than it was written first. Typically, any element except oxygen or hydrogen is the best place to start if you're stuck on balancing an equation. When I look at phosphorus, I see that I have 1 on the left and 2 on the right. I add a coefficient of 2 in front of the phosphorus, which gives me 2 phosphorus on the left and 2 phosphorus on the right, so now the phosphorus is balanced. However, my oxygen is not. I have 2 on the left and 5 on the right. I need to figure out what coefficients I can put in front of both of those species in order to get an equal number of oxygens. So the lowest common denominator for 2 and 5 will be 10, which means I need to put a 5 in front of the O2 to get 10 oxygens, and a 2 in front of P2O5. When I do that, I will change to having 4 phosphorus atoms on the right and 10 oxygen atoms on the right. So now my oxygens are balanced, but my phosphorus is not. However, I can go back and change the coefficient for phosphorus to 4 on the left side, and I end up with 4 phosphorus atoms on the left and 4 on the right. The coefficients go through all the elements in a particular compound, so we have 2 times 2 for phosphorus on the right and 2 times 5 for oxygens on the right. Let's look at the reaction of propane, C3H8, plus oxygen to form CO2 and water. I'm going to set up my table to count how many I have of each element on either side of the reaction. And I see that I have carbon, hydrogen, and oxygen present in this equation. On the left, I have 3 carbons, 8 hydrogens, and 2 oxygens. On the right side, I have 1 carbon, 2 hydrogens, and 3 oxygens. Note that I have oxygen present in 2 different substances on the right side. Whenever we're balancing, if you have an element that's present in 2 compounds on the same side of the equation, it's best to save that one to last in order to balance it. I'm going to start with my carbon and add a 3 in front of the CO2, which means I now have 3 carbons and 7 oxygens, because 3 times 2 is 6, plus 1 more from the water is 7. I see that my carbons are now balanced, but my hydrogens are not. I put a 4 in front of the water, which gives me 8 hydrogen atoms and a total of 10 oxygen atoms. 6 from the CO2, because there are 3 of them, plus 4 from the water, because it's 4 times 1, for a total of 10 oxygen atoms on the right. I now see that my carbons and hydrogens are both balanced, but my oxygens are not. If I put a 5 in front of O2, I end up with 10 oxygens on the right, and I have a balanced chemical equation. Note that there is some trial and error involved in balancing an equation. If you try to balance and you're getting stuck, sometimes the best thing to do is start fresh and try a different approach. Let's look at another reaction involving a hydrocarbon and oxygen. C2H6 plus O2 yields CO2 and water. We set up our table to count how many we have of each element. We have carbon, hydrogen, and oxygen. So 2 carbons on the left, 6 hydrogens, and 2 oxygens. On the right, we have 1 carbon, 2 hydrogens, and 3 oxygen atoms. We're going to start by balancing our carbon atoms. So I'm going to put a 2 in front of the CO2, which gives me 2 carbons, but it also changes the number of oxygen atoms to a total of 5, because 2 times 2 is 4, plus 1 more from the water gives me 5. I'm going to save the oxygen for last because I see that I have oxygen present in both of the products. Next, I'm going to look at my hydrogen atoms. I see 6 on the left and 2 on the right, so I add a 3 in front of H2O, and that gives me 6 hydrogen atoms, and it changes my total oxygens to 7. 4 from the CO2 and 3 from the water. I see that both my carbon and hydrogens are balanced, and oxygen is the only thing that's not balanced. However, there's no whole number that I can put in front of O2 that will multiply times 2 that's in the subscript to give me 7. What we're going to do for a moment is pretend that that 2 is not there on the subscript. What number would I need to put in front of oxygen in order to get 7 oxygens on the left side of the equation? 7. If I put a 7 in front of oxygen, assuming there's no subscript with it, then I would have 7 oxygen atoms. However, the 2 is there. It is a diatomic molecule, so I have to take that into consideration. But I can change this to 7 halves. 7 halves times 2 is equal to 7. This gives us the same number of carbon, hydrogen, and oxygen atoms on both sides of the equation. However, remember our rule that we want to always use the smallest whole number coefficients to balance a chemical equation. If I need to get rid of that fraction that has a 2 in the denominator, I would need to multiply that value by 2. If I multiply one coefficient by 2, I must multiply all of the coefficients by 2. So I would say 2 C2H6, 7 halves times 2 would be equal to 7, 2 times 2 is 4, and 2 times 3 is 6. Now, when I go through my equation, I see that I have 4 carbons, 12 hydrogens, and 14 oxygens on the left side of my equation. On the right side of my equation, I have 4 carbons, 12 hydrogens, and 14 oxygens. Now I have a balanced chemical equation with whole number coefficients.